In this question, a negatively charged rod is held close to one side of a metal sphere and the other side is Earth. Which diagram shows distribution of the charge on the metal sphere? What could be the answer? So D is the right answer. Because what happens when you bring a negative charge rod? So like charges repel, unlike attract, and electrons will move out. So when a majority of electron will move out, so most of the positive charges on one side. Why this is not answer? Because it is not like equally distributed, because there's a charge rod. That's why most of the positive charges are towards the charge rod. A student rub a plastic rod with a cloth. The rod become positively charged. What has happened to the rod? So it become positively charged. So why it become positively? Because it lose electron. When something lose electron, it will be positively charged. Which quantity is measured in coulomb? What is the unit of the charge? The unit of the charge is actually coulomb. So A is the right answer. Unit of current, later you will learn, it is ampere. Unit of EMF, electromotive force, is volts. Unit of power you already studied, that's watt. So the unit of the charge is actually coulombs. Question 5, what could be the answer? A polythene is rubbed with a cloth. A polythene is rubbed with a cloth. The rod become positive charge. So if rod become positive charge, it means it lose electron. Which charge particle? So either A can be answer or B. And then direction of the movement, because the rod become positive, so it is from rod to cloth. So that's why B is the right answer. Is it clear? Because the rod become positively charged. So if the rod you rub with a cloth and the rod become positively charged, so it means the electron jump from rod to the cloth. This is a structure question. In figure 8.1, S is a metal sphere standing on insulating base. R is a negatively charged close to S. Name the particle in S that moves when R is brought close to S. Which particle will move in S when I will bring R closer? So electrons will move, so electrons shifted. So here you will have majority electrons and this side majority will be the positive charges. So answer here is electrons. Then on the figure 8.1, add positive and negative sign to suggest this movement. So on the left hand side, what I will have, positive or negative? on my left. So it will be positive. You can draw on the metal, okay, or you can also draw on the surface. Both are correct. Because some students just draw on the surface, that's also correct. Some students draw on the metal, that's also, both are correct. But you have to keep in mind, if you are making 4 positives on the left, so there should be 4 negative on the right, equal number. It is not, no, not according to how many are here. It's not necessary how many are on R. If you are bringing 4 positive, 4 negative will be there. This is important within the metal. In R, it can be any number, but when you show a distribution, it should be equal distribution, equal number. Like if you draw 3 positive and you draw 4 negative, then this, your answer will be wrong. Describe the action which now need to take place so that S become positively charged. So if you want to make it positively charged, so what action we should take? If I want, yeah, that's correct. Connect an earthing wire. So what I will do, I will connect an earthing wire. So the action will be connect earthing wire, which remove most of the negative charge from S. Then to make it permanently, positive charge, remove the earthing wire. Sorry, yeah, remove the earthing wire. Then the charge rod. So this is the answer for this part, which they say what action you should take. What action you should take so that you will make it permanently positively charged. Is it clear? And the next question, electric field we'll discuss tomorrow. That's why I leave the question related to electric field. Conductor A is given a positive charge as shown in a figure. On figure 9.1, mark the sign, the charge induced at X and induced at Y. What will be the charge at X? Yeah, so X will be negative, and what is the charge on Y? So Y will be positive. And it should be equal number. If you are making 4 negative, so it should be 4 positive. Explain how these charges are induced. So you have to explain this process, how this happened. So what happened? You have to just use the idea that the positive charges on A will attract the electron. So they move towards, so positive charges on A will attract the electrons. So they move towards left hand side. And you can mention, first thing you will mention, like charges repel and unlike charges will attract each other. So electrons attracted towards positive charge sphere A and positive charges. So positive charges on A attract the electrons on negative charges, and unlike charges attract and like charges will repel. So as these electrons, so like charges repel, unlike charges attract, so electron attracted towards the positive charge sphere, which create distribution of the charges. Because it is obvious, if electrons are moving towards one side, the other side will be positive. Why the charges at X and Y are equal in magnitude, means equal in number. If there are if there are four positive, negative, there are four positive. Why they are equal in number? What's the reason? Yeah, because originally it is neutral. So because there is no loss or gain of electron from another material, what happened basically, if this was an atom and electrons are revolving around the nucleus of an atom. So as these electrons move towards one side, this create a positive charge, that or ion will move towards another side. So you will mention here why X and Y are equal in magnitude, because the metal originally it was neutral. So electron loss or electrons move out from atoms, create equal number of positive and negative charges. Is it clear? Because the metal was neutral originally, so when the electrons move out from atom, it will create equal number of, if one electron will come out, so there will be one in negative charge and one positive, so the overall it will remain neutral. Then they mention B is now connected to earth. So this B, after creating a distribution of the charge, we connect there with earthing wire. This is a symbol for earthing wire. Now what happens if I connect this to earthing wire? Electrons will move from metal B, metal sphere, the sphere B to earthing wire, or it will move from earthing wire to the sphere B. What will be the movement of electrons? Towards sphere B or away from sphere B?
Towards.
So from ground or earthing wire to the sphere. So what will be the net charge here?
Positive.
No, net charge, because mostly electrons enter now. So what will be the net charge? There are positive, but majority of them are negative, so net charge will be negative. So if I say this was originally, this is negative, okay, and this one is positive. When you connect an earthing wire, electron enter. So as these electron enter, what will be the charge on Y and what is the charge on X compared to the original charge? That's the next question they ask. So when you compare the charge at X and charge at Y, what will be the charge at X? Will it change? What will
At
be the
X it will be what? It will be negative.
X will remain negative. There is no change for X. Originally it is negative and now also it remain negative, because what happened? The negative charges from the earthing wire move to the metal sphere. So it will still remain negative and no change. But what happened to charge at Y? So Y will be 0 because electrons enter and neutralize the positive charge. So Y will be 0 charge or neutral charge, because equal number of electron enter to neutralize them. Is it clear? The electrons actually move from earthing wire, so they neutralize the charges at Y. So Y, net charge on Y will be 0 and net charge on X, already there is a negative charge, so it remains negative. From earthing, electrons, because they are free, like electrons, because of their size and due to weak attraction, they can move easily. What's your question? The electron that are weakly attracted will go away and be distributed, and like from earthing wire, either electrons can move out or they can go in depending on the charge you bring. Example, if I bring here example, if I bring a negative charge rod, a negative charge sphere, what will be the charge at X? So charge at X will be positive. What will be the charge at Y? Negative. And if I connect an earthing wire, so if I connect an earthing wire, so what happens? Because this negative charges is repelling these electron, so these electron will go out. So as these electron will go out, when we connect an earthing wire, so after connection of earthing wire, the charge at X will remain positive, but charge at Y will be 0, because the extra electrons go away from this sphere or move out from this sphere. Is it clear, the concept of electrostatic? So we started with the concept of the charge atom. Then how we can charge an object is either by rubbing or by induction. And if we want to if we want to remove extra charge from the material, so we can connect an earthing wire. Any doubt related to this class? Okay, so I'll end the session and share the recording with you.